Hey, hey, yo, 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 what's up? Mr. G here, and this is the video for writing linear equations from situations and graphs. Hope everybody's doing well. It's good to see you all, even though I can't see you. I can feel you. I know that you're here, and I'm excited that you're watching. All right. So, what we're going to be doing, we're going to be reading some word problems today or looking at some graphs, and we're going to have to write a linear equation from that situation or that graph. So the first thing we need to know is what form should a linear equation be in, and it should be in slope-intercept form. Okay, if it's a linear equation, that word linear means we're going to be in slope-intercept form. Okay, because, I'll write that down, slope-intercept form, because slope-intercept form gives me a straight line, an equation that goes into a straight line. Okay, word linear means it is an equation that's going to make a straight line. So the graph, if I had to graph this equation, it should be a straight line. That's why that word line right here is in the word linear. Okay, now slope-intercept form is y equals mx plus b. You should know this already. If you do not, go watch a previous video about slope-intercept form. Okay, now in slope-intercept form, at this point, you should also know that the m represents the rate of change, or the slope. Okay, and I call it rate of change as well because it's really representing the thing that's changing, and we're going to talk about that in a second right here. And this is my y-intercept. My y-intercept is also the initial value, or sometimes it's just a one-time fee when we're dealing with word problems. Okay, so y-intercept, slope, those are the two items we're looking for. So I want to write an equation that's in this format. So let's look at the first scenario. I have a video club that charges a one-time, this is important, one-time membership fee plus a rental fee for each DVD. Okay, so one-time membership fee plus a rental fee for each DVD. So what we know is, from this, we want to use the graph to write an equation in slope-intercept form that represents the amount spent y on x DVD rentals. So I'm going to write an equation that looks like this. Okay, it says the amount spent y. So if I write it looks like this, the amount spent, my y represents the dollars spent. So what I'm doing is I'm taking my slope-intercept form and I'm just rewriting it. So y represents dollars spent. I know that's going to represent whatever my slope is times x. The x is the number of DVD rentals. It gives me this information right here, number of DVD rentals. So I'm going to label everything. And then that's going to be plus whatever my y-intercept is, okay, or that initial fee. So notice how I underline these certain values here. A video club charges a one-time membership fee. I think that one-time membership fee is going to be one-time membership fee, my y-intercept. Okay, membership fee. So my y-intercept is the one-time membership fee plus a rental fee. There's the plus, the rental fee for each DVD. This is the number of DVD rentals. Each means multiplication. So the thing that is changing, my rate of change, is depending on, is what's going to be different every month, is going to be how many DVDs I rent. So this is the rental fee. So we already know what each piece of the equation means. Okay, the slope is going to be whatever the rental fee is because that's my rate of change. I'm going to pay each month based on how many actual DVDs I actually rent. Okay, so that's what's going to change the cost. The one cost that's the same every single month is this one-time fee right here. Okay, and then we also know that x is the number of DVD rentals, y is the dollars spent. Now I got to actually know what these values are. So what I'm going to do is I'm going to take a look at my graph over here to determine what my values are. So if we look here, if I don't rent a single DVD, so here's my x-axis right here is my amount of rentals. Okay, so looking at this graph, if my x value is the number of rentals I have and the amount of spent is my y-axis, if I have 0 movie rentals, DVD rentals, I am still paying $8. Well, that must be that one-time membership fee. Okay, so that one-time membership fee, if I haven't rented a single DVD yet, but I had to pay my one-time membership fee, then that means I have paid $8. So that means my one-time membership fee is $8. Okay, because I haven't rented a single DVD yet. X is 0, okay? My y-intercept then is 8 because the amount spent is $8. That's where I'm starting. Your starting point, your initial fee is $8. So my y-intercept always represents my starting fee, my initial fee. Then I have to pay a rental fee for each DVD borrowed. Well, if we look here, okay, it looks like our X values are going by 2s, okay? Our Y values are also going by 2s. And then it looks like, it's hard to find a perfect point, but like I have a perfect point like right here. Okay, so it's hard to, the graph's a little bit difficult to read. But my perfect point is right here on 18 and 8. 18 and 8. Okay. So really it looks like I can actually read my slope by doing my rise and my run. To go from 8 to 18, I go up 10. And to go from 0 to 8, I go up, I go over 8. So my rate of change or my slope or my rental fee is going to be 10 over 8. Or I can actually do that 10 divided by 8 to figure out what it equals. Okay. Now 10 divided by 8, just to save us time, is $1.25. If I do 10 divided by 8, it goes in once. I say to save us time, and here I am doing it. Decimal, bring down my 0, 8 goes into 20 twice, and then it's going to eventually be $1.25. So that means they charge $1.25 for every DVD rental. That's my rental fee. And there's my rate of change. That's how much we're changing by each and every single time. Okay? So I can look at my graph and I can find my slope by calculating my rise and my run. Now these are all points, but this point, I don't know exactly what value that is here. I know it represents 2 rentals, but I don't know how much money I spent. So I was looking for that perfect point. I found it right there. And then I did my rise and my run to figure out my slope. I have my equation. Every single piece of that equation has a certain purpose or value. This y represents the dollar spent. Okay, this slope represents a rental fee. The x represents a number of DVD rentals, and we know that x is DVD rentals, y is the amount spent. That's what it tells us on our graph. And then my initial one-time fee is my y-intercept. All right, let's go a little bit faster through these next couple ones. So, cash register subtracts $2.50 from a $25 coffee cafe gift card for every medium coffee the customer buys. Use the graph to write an equation in slope-intercept form to represent this situation. So I know it's in y equals mx plus b. That's slope-intercept form. Okay. It looks like if I look at my y value, these are my dollars spent. Okay. And then the x values are the number of coffees. So it looks like the rate of change here is the $2.50. Okay, from a $25 coffee cafe gift card. So I'm subtracting $2.50 each time. Notice how my line is going downhill right here. Okay, it's going downhill. That's the direction it's going. That means I know I have a negative slope. So my y is going to equal a negative slope. And the rate of change here is it's going down. It looks like $2.50 each and every single time. I know I'm going from 25 to 0, so my rise is negative 25. If I'm counting my rise and my run from here to here, I'm going down 25. And it looks like I'm going over 10. If I do negative 25 divided by 10, I will get negative 2.5 or $2.50. So there's my rate of change, and that's for each cup of coffee. Okay, so this is coffee cups. My y represents dollars. We already figured that out, how much money I actually have. And then, but my starting fee is I started off with a $25 gift card. And so there's my initial amount. Okay, we started with a $25 gift card. There's my y-intercept right here on the graph. It's crossing at $25. And then I'm subtracting $2.50 for each cup of coffee I get, because that's how much they cost, and that's how much money I have left on my gift card. But there's my final equation. But make sure the biggest part is that it's negative because we're spending money from that gift card, and it's a negative slope because it's going downhill. Okay? Okay, the rent charge for space in an office building is a linear relationship related to the size of space rented. Write an equation in slope-intercept form for the rent at West Main Street Office Rentals. So here's West Main Street Office Rentals. Okay, so let's make this a little bit bigger. Monthly rate, 600 square feet for $750, 900 square feet for $1,150. Okay, so what we're looking at here is we have two different possibilities. I have a monthly rate for 600 square feet, and I also have a monthly rate for 900 square feet. Okay, so what it's looking for, or what we need to figure out, is what is the slope, or what is the rate of change. Okay, so what we have here is we need to identify input values and we need to identify output values. Okay, because really the cost is going to be per square foot. So what I know is if 600 feet is $750, that means the amount of square feet is going to determine the cost. So there's my input. The amount of square feet is going to have the impact on what my output is. Okay, so the amount of square feet determines the cost. So that gives me a point of 600 feet and $750. There's my X value, there's my Y value. I also have the point of 900 square feet and $1,150. Because this is my square feet determines the amount of rent I spend. So that's why I have my X value is the amount of square feet. The Y value is the output, because the amount of money we spent depends on how big the office is, how many square feet it is. Now I can find my slope from this situation. I can subtract my Y's and I can subtract my X's. Okay, I'm subtracting my Y's, subtracting my X's. So I can do 1150 minus 750. I'm subtracting my Y's. I'm also subtracting my X's, because to find the slope, we could do y2 minus y1 over x2 minus x1. I'm finding the change in y and the change in x just by doing a quick subtraction problem. Okay, 1150 minus 750 is 400. 900 minus 600 is 300, which can be simplified by getting rid of these zeros. I have 4 over 3. Okay, so now what I do is I figured out the rate of change. I figured out the cost per square foot. Okay, it looks like they're charging $4 for every 3 square feet. Okay, $4 per 3 square feet. So there's my rate of change. Now what I need to figure out is, what is my y-intercept? This is the tricky part. What is my y-intercept? What was the initial fee that what's the initial fee that they're charging us? Okay, and so the way I do that is I actually use slope-intercept form, y equals mx plus b, to find my y-intercept, this initial starting value that they charge. Okay, so what I can do is I can take either one of these points. This is an x and this is a y. This is an x and this is a y. I can take either one of these points and plug it in to my rule. So this is getting a little sloppy, so I'm going to erase some of this just so we can see this a little bit better. Okay. So I have this point right here, 600, 750. I can plug this into my rule where 600 gets plugged into my x and 750 gets plugged into my y, because this is an x and this is a y. I also know what my m is right here. Okay, that's a weird circle, but I also know my m is, so I can plug that in as well. So I'm taking an ordered pair from I'm taking one of my monthly rates, I'm just plugging in, and I'm going to solve for b. I have to solve an equation. So 750 is my y. That equals 4/3. There's my m, right? There's my slope. And I'm multiplying that by 600, and I don't know what my y-intercept is. So now I can find it. Okay. Now the tricky part is going to be multiplying the fraction, right? But that's why we always want to cross simplify if we can, because 3 goes into 6 twice, which means 3 goes into 600 200 times. 4 times 200 is 800. Okay, so I have 800 plus b equals 750. I can subtract 800 from both sides, and I get negative 50 equals b, so I figured out my y-intercept. So now I have my y-intercept, I have my slope, I can finally write an equation. So let me erase a little bit more for you here. and y equals mx plus b. So that means I have 4/3 x, that's a weird x, sorry, minus 50. 4/3 x minus 50. That would be my equation for this particular situation. Okay? All right. Now, we've got one more, and then we'll be done. I know we're getting through it, but sometimes word problems can be tricky. Okay? But first, I got a question for you, or a joke, if you will. Where is the best place to do math homework? So where is the best place to do math homework? On a multiplication table. Ha ha! All right. Here we go. We're moving along here. Okay. Try this one on your own first, and if we just don't get it, we can watch. But see if you can write the equation first on your own. Harry's weekly allowance varies depending on the number of chores he does. He received 16, so the number of chores he does determines his allowance. So there's my x values, the number of chores he does, and then his allowance is my y value because this is my output. Whatever is the part that determines the other one is the input. So because the number of chores he does is what's going to determine the amount of money he makes, the number of chores he does, that's my input. That's my x value. So he received $16. That's so we know the allowance, the money he makes, is my output. I don't know why I did that weird line. So there's a y. In a week he did 12 chores. So there's my x for that. So 12 chores for $16. $14 in allowance, so there's a new y. When he did 8 chores, he made less money because he did less chores. That makes sense. But the amount of chores he did determine the amount of money he made. There's another point. So now I can figure out my rate of change by subtracting my y's and subtracting my x's. Okay. I get 2/4, which is 1/2. If I wanted to make this into money, we know 1/2 is equal to 50 cents or 0.5. So he's making 50 cents per chore. So right now I know my equation is going to be the amount of money he makes is going to be determined by 50 cents per chore. Now I just got to figure out, does he make an initial allowance fee already? Okay. Does he start off by making a weekly allowance without doing any chores? And it looks like he does, because I don't think he could have made 6 from doing 14 chores. I don't think he would have, from doing 8 chores, he wouldn't have made $14 by making 50 cents a chore. It doesn't make sense. So we've got to figure out what that initial allowance is. So I can take any one of these points, either one of these points. This is an x, this is a y. Pick the point that you want. It doesn't matter. Okay, I can pick this second point because that's smaller numbers. We like smaller numbers. And I'm going to plug it in for my x and my y, knowing what my rate of change is. So my y is 14. My rate of change is 50 cents per chore, $8, but we don't know what that starting value is, so I'm going to write plus b there. Now I'm just going to solve my equation. Okay, so I'll write it over here. Okay, now I'm going to solve my equation. So I have 0.5 times 8, so it's 50 cents times 8, half of times 8, 1/2 of 8. If you can work it out, but you're going to get 4. And I'm going to rewrite everything else I have. So I have 4 plus b. So to get rid of the 4, I would subtract 4 because 4 minus 4 is 0. So I subtract 4 from both sides, and I get 10. So that means they get an initial starting allowance of $10 for doing no chores, plus 50 cents per chore after that. Okay, that's it. I hope this helped. This is going to take some practice, so good luck. Take your time, and let me know if you have any questions. All right, thanks, guys. Gradius out.